So in our second video, we're going to talk about average atomic mass. So our leading question is, what is the difference between mass number and average atomic mass? They both have the word mass in them, but what is different about these two numbers? So we're going to start with mass number. Remember from our last video that mass number are what contain the subatomic particles that contain mass. So that's going to be our protons plus our neutrons. But there's a difference between mass number and average atomic mass. When we say average atomic mass, we're taking the average mass of all isotopes based on their abundances. Our example for isotopes in our last video was carbon. We talked about we had carbon 12, carbon 13, and carbon 14. So with these three isotopes of carbon, the average mass is 12.01. This tells us that the mass, based on abundance, carbon 12 is the most abundant isotope of carbon. There are isotopes of carbon 13 and 14, but they have such little abundance that they don't pull that average very far away from 12. This is not an average where we add them up and divide by 3, otherwise we would get an average of 13. This is a weighted average, and so we're going to talk about the math that's involved in a weighted average. So the place in your life where you've talked about weighted average the most has been with your grades. So weighted averages, if we talk about our class, 85% of your grade comes from what we do in our class, and 15% is going to come from that state EOC. Now, let's say it's getting near EOC time, and you don't want to lose that A, right? And you're thinking, what do I need to get on the EOC? So we're going to do some weighted average math here. Let's say in the class you have an 89.5, which is the lowest A possible, right? Because that 89.5 rounds to a 90. With your 3 points, you get the 93. You get to keep your A. This is the grade that you want at the very, very end of class. So what makes up this final grade is that 85% or 0.85 comes from your class grade. And let's say in your class grade you also have an 89.5. You just want to keep that low A. And we're going to add that to 15% or 0.15 times whatever you need to get on the EOC. So we'll make that an X because I know how much you guys love the letter X. So now we're going to just solve for X. 0.85 times 89.5 gives us 76.075. So I need to subtract that on both sides of my equation. 89.5 minus 76.075 gives me 13.425. And now I need to divide by 0.15. So you would need to get an 89.5 to keep an 89.5 to get an 89.5. Let's do that again with a different scenario. Let's say in the class, which is 85%, you have a 74.5. So a 74.5 is one of the lowest C's you can have. And you're like, oh, Miss Haverdays, I really want, can I bump it to a B? Well, let's see. What's the lowest B you could have? So the lowest B you could have would be an 84. Nope, lower, 81.5. Because an 81.5 rounds to an 82, 3, 4, 5. Yep, that gets you the 85 with the 3 points added. So let's do this math. 0.85 times 74.5 gives me 63.325. Subtract 63.325 on both sides. That gives us 18.175. And then divide. You would need to get 121 on the EOC. Wonk, wonk. That's not going to happen. So the best thing you can do is increase this 85% in class so that then you can propel yourself to a higher grade if that's what you would like to do. So make sure that you're studying now instead of waiting till later. A weighted average is going to be the same when we talk about average atomic mass. And so if we have isotopes, they contain a mass, and that mass is in average with their percent abundances. So let's say we have 2 isotopes of copper. Copper 63 and copper 65. Copper 63 is, what? I don't know. I'm going to have to make this up right now. 65% abundant?
I have no idea. I wonder if that movie is making them hear the shouting.
35% abundant, because it has to be 100%. So if these are our percent abundances and these are our masses, to find the average mass, you take the percentage, not in the percent form, but in decimal form, times the mass that it goes with, and you need to add that with all other isotopes. So the percent abundance times its mass, and then you would add those together. If we had 3 or 4, you could continue this. So 0.65 times 63 is 40.95. And 35% times 65 gives us 22.75. If we add those together, we get an average of 63.7 as our average mass. If this was our average mass, right, we always know if it's an average, it has to be between the 2 mass numbers. So if we're averaging 63 and 65, you can't get 200, nor can you get 4. It does have to be between the 2 numbers, and it should be closest to the one that has the highest percent abundance. Because copper 63 is 65% abundant, then our answer should be closer to 63 than 65, which it is. So happy face. The last thing we need to talk about is a little bit harder, and that's finding the percent abundances. The average masses are posted for us on our periodic table, and so what we need sometimes is to find how abundant they are. So we'll do boron as our example. Boron has 2 isotopes, boron 10 and boron 11. And when I look at the periodic table, boron has an average mass of 10.812. How can we find the average, the percent abundances of each of these isotopes? So one thing we know is that the average equals the mass of each isotope times its decimal percentage. When solving for this, you might want to do like an x and a y, but we don't have 2 equations, so we need to find just one variable. So let's say we make this one x. So if I'm solving for x, the percent abundance has to be equal to 100, but I want it in decimal form. And 100% in decimal form is the number 1. So 1 minus x will give us the other percentage for the other isotope. And then we can solve using algebra. So 10.812 equals 10x plus, I'm going to distribute 11 plus 11x. No, minus, sorry. 11 minus 11x. Then I'm going to combine my like terms. So 10x minus 11x is negative 1x. And 10.821 minus 11, 812, sorry, minus 11 is negative 0.188. If you want to see the divide by negative 1, I will show that for you, but you should understand that 0.188 is going to equal x. Or that's our decimal percentage, therefore x is going to equal 18.8%. X went with 10, so that's going to be the abundance of boron 10. To find the abundance of boron 11, you can either plug this x back into 1 minus x and get your decimal and then multiply by 100, or you can take your 18.8 and minus from 100. So 100 minus 18.8, 81.2% would be the abundance of boron 11. And that's how we can solve. Have fun with your PL, and hopefully we will be in school. They can do some stuff on their own, but some stuff they just can't.